everyone. I hope a few more people will be joining. So I'm very happy to welcome two speakers today. So we have Dr. Valentin Ouedraogo, based in Burkina, who's going to be presenting about work done with Wascal on working on applications that should be useful to farmers, and also they've already deployed this, so it's going to be a very hands-on, so that we can learn something about how data and applications can be used in the field, how they can be helpful to communities, which is, our goal in the project. And then afterwards, we'll have Balbina Nyamakura, who is a PhD candidate here at IHE Delft. And this will be, I think, a little bit more maybe theoretical on approaches to co-development. And for her, it's in the context of climate change and climate data. So I'm very happy to have the two of you. The plan is that you present for about maybe 15 minutes or so. And then we have time for questions and discussion. So looking forward to that. I'll ask everyone not presenting to please mute their microphones. And I'll give the floor to you, Valentin. So if you want to share your screen.
Okay.
Sorry, I accidentally muted you, Valentin, so please unmute yourself. I was trying to mute other participants.
Okay.
Okay, perfect. Are you able to share your screen?
Yes, I'm trying to do that.
You're having a perfect. I see. Looks good.
Okay.
It's not in presentation mode yet. Perfect. Thank you. Okay.
Okay. Can I start?
Yes, please go ahead. The floor is yours.
Okay. Thank you. Good morning, everyone. My name is Valentin Ouedraogo. I'm working at Wascal. Initially, I'm a climate scientist, but I'm working at Wascal as a GIS and remote sensing scientist. Then I'm dealing with everything about data, geospatial data that can help to deal with climate-related issues in different domains. And today's presentation is going to be about one project we co-developed and co-implemented with the Ministry in charge of Agriculture of Burkina Faso. And the project name is Precision Pest and Disease Management System based on multidimensional big data, PEDMAS. These are the technical and financial partners we work with. How did we got to this project? We observed, and also we read, we heard people talking, and also we saw a proof through our analysis statistics that in Burkina Faso and also in most of the West African countries where we know more, the problem issue related to farming is mostly due to the attacks of pests and diseases. And these attacks can cause yield loss. It can even cause a total yield loss if the attack happen at a certain time during the crop development cycle. And then we saw a call for proposal from Agridi, financed by the European Union, and we decided to draft this project related to crop and disease management. We had two main objectives. The first one was to develop a mobile app that can help to control pests and diseases on crops. This one is we assume that the pest or disease is already there, it's in the crop, but how to control it, how to know which pest it is or which disease it is, and how to combat it. And this was the first objective. The second one was develop an early warning system that can help to prevent the occurrence of the crops. But today's presentation will focus on the mobile. At the beginning, we conducted this project in collaboration with the Ministry in charge of Agriculture of Burkina Faso. How the mobile app works. We worked on three crops: maize, tomato, and onion. It's not like in Burkina Faso we only farm maize, tomato, and onion, but we try to be a bit inclusive. We choose maize because it is one of the main crop practiced by most of the farmers. And we choose tomatoes and onion because they are gender inclusive. In maize and tomato farming, we can most of the time find women and also young people working there. And we wanted to carry everyone along the project. And then we conducted data collection on the ground, and we used the the agricultural extension agent on the ground. We provided them with a smartphone where we pre-installed the application to collect the data and send it automatically into the database we manage. And we also collect images on existing pests or diseases we found on the ground. Collect the images on disease crops, and we also collect the images on healthy crops. And at the end, we use the images we collected together with the other information, and we run a deep learning algorithm. And we did a number of tests that was successful. And finally, we were able to produce a beta version of the application. When you go to Google Play Store, you can find the application. The name is PlantSen. We decided to put the name in French because our study area was mainly in Burkina Faso. That is a French-speaking country, even though we know that most of the farmers, they don't speak French. They speak their local language. But for the first draft or the first version of the application, we put it in French to help some people that are some knowledge to use it, to find it easily. When you go to Google Play Store and you type PlantSen, you'll find the application. You download it. It is free. You download it. You can install it on your smartphone and use it. Before I shift to the practical one, I want to mention that this application is only working in maize, tomato, and onion farms, because we worked on pests and diseases related to these three crops. It's true that we can find the same pests or diseases for many crops, but for now, the advice is that we use the application when you are in a maize farm. You can use the application in a tomato farm or in an onion farm. When you are in a sorghum farm, we are still working to test whether we can use the application in in the sorghum farm, for example, if the pest or disease we find there is the same, then we can find in maize farm, for example. But as for now, the advice is to use it for the 3 crops only. I will shift to the practical session and also talk about some lesson learned during this project implementation. Can you see my screen, please?
Yes, we can see the application background.
Okay. This is the application, how it shows in your phone. Once you download it, you register and you have an account. I have already registered and I have an account. When you open it, it will ask you to put your credential to be logged in. And when you log in the application, this is the window you can see. Here, you can see the 3 crops: maize, tomato, and onion. Depending on which crop you want to work in, you select it. If you select it, it will take you to a page where you can proceed. Before we go there, you can see the last line, so that it's written in French. When you click here, for example, the first one, and you click there, you can see the different pests and diseases we met on the ground during the data collection per crop types. You can see fall armyworm, you can see healthy leaves, and other diseases and pests related to maize, tomato, and onion. Okay. If I go back, assume that we are in the maize farm and we found some diseases or crops and we don't know what they are. We want to use the application to identify them and benefit from some recommendation on how to deal with them. Then I click on maize. It will take me to this window telling me how to use the application to identify the pests or diseases I found on my crop. As you can see, you use it and you activate your phone camera and you just take a photo. And if you go down, there is 2 options. The first one is to take a photo, and the second one is to select a photo on your gallery. If you already have a photo saved in your phone, you can go and take this photo and ask the app to identify it for you. In our case, how we are not on the ground right now, I already have an image on my computer. We'll go there and ask the app to identify the photo we have. It is a photo of a pest, and we will see what it will tell us. We click there. We click this photo. If you select the photo, we also customize the app in such a way that if you have a bigger image or a bigger area, and you think that the overall area is not useful for the identification, you can subset your image. You subset it and you limit it only to the pest or diseases area, so that the application will have a better possibility to identify your your pest or diseases. But here we will leave it as it is and submit it to the system. If you submit it, this is how it shows. The first one on top is the images I submitted. But the 6 images down are images similar to the one I submitted, the application shows me. And the application is telling me these 6 images to me are similar to the one you submitted. If you think that the image you submitted is among the 6 one, then the name of your pest is fall armyworm. This is how it works. The application has a number of data on the database, but it still needs human intelligence to confirm whether the pest or diseases you submitted is really what is in the database. That's why I said the farmer can use it. It helps the farmers to save time and resources, because in the context of Burkina Faso, we don't have the number of extension services, extension officers is limited, and we can have one extension officer for 3 or even 5 villages, and the villages are far away or is other. And for example, the farmer can use it, identify the pest or disease, and call the external officer, tell him, I found this and that pest or disease on my farm. Can you come and help me? And this can help to save time and also save resources. Yeah. But if it is the external officer who uses the application directly, it helps him also save time and resources. Sometimes he will go on the farm, he will see a pest or disease, but he need to go back to his office to look at his note to identify the pest or diseases he found on the farm. But using this application, it can help him save time and resources. And if you identify the problem on your farm, the following information are some recommendations, some precautions you have to apply, maybe to limit the expansion of the pest or diseases while waiting for further intervention of the agricultural extension officer. What I want to add regarding the application is that you need only internet connection to download the application and do registration. After the registration, you can work offline. You can use the application offline. And then even if you have your farm in a remote area, you can use it. You need to go where there is internet, download it, register, and go to use it. You need again internet if you want to communicate with the administrator. If you found that there is some malfunctioning of the application, or you found a new pest or diseases, or you have a question, you need internet to be able to send the message and also receive the feedback from the administrator. What I want to add before ending my presentation is that we learned some lessons when we were implementing this project. The first one is collaboration, co-creation. At the beginning of the project, we worked together with the Ministry in charge of Agriculture. We went to them and asked them, what is your problem? What is your priority in terms of crop pests and diseases? And they told us the number of the names of pests and diseases they have difficulty to fight, and they oriented us at the beginning of the project on how we should work so that what we are going to produce will meet their expectation. This is the first thing. And the second thing is that the Ministry of Agriculture is a public service. And during this project, we also use drones. We use drones to fly to map the disease farm and also the healthy crops. But the Wascal project was the first one to use drone and also identify the drone according to Burkina Faso's law. And then since we were the first institution, the process was too low, and it delayed the implementation of our project on the ground. But fortunately, with the intervention of Ministry of Agric, we had a special authorization to use the drone and do the work. In addition, we included a number of farmers on the ground, because what we observe is that if you sit on your office, you develop the project, you develop your tools, and at the end you go to hand it off to the farmers, they may tell you, no, this is not what we needed, and the adoption will not be good. And then we went to the ground, we discussed with a number of farmers in collaboration with the extension officers. We explained to them what we wanted to do, and they agreed. And during the process of data collection, they were together with us, and they will help us to select the farms and to do the work. And then at the end, when we completed the development of the application, when we went back to the farms, they were happy. And we even trained a number of them to how to use the application. And some farmers are even like models. The other farmers can learn from the ones that we worked with. And when we were doing the training, we observed that this method was the best one. If not, if we haven't done it that way, at the end, we would have some issues regarding the adoption of our application. And then I can say that the co-development, the co-creation method we adopted help us to achieve our objective, and also to meet the expectation of the end users of the application, who are the farmers and the agricultural extension officers on the ground. Thank you.
Thank you very much. Well, I'm going to invite people to ask questions. I actually have a first question just before I move on to the room. I was wondering if did you have any surprises when you were doing the co-creation? Anything that maybe in the design that was changed based on that interaction with the farmers?
What I consider is that at the beginning we were targeting the farmers with who have smartphones. Because without smartphone, you cannot use this application.
Yep.
But at the end, we observed that if we want to target only the farmer with smartphones, we will not have many farmers to use the application. And what we did is that to also invite some farmers without smartphone and ask them to learn with their colleagues or their neighbors who have smartphones. And this is what we did at the end.
Okay. Yeah, interesting.
Yes.
Yeah. Thank you. I see, Balbina, you have your hand up also.
Yes, thank you so much for the presentation. It's actually very interesting. I wanted to ask, what kind of maintenance does the app require?
In terms of maintenance, is to be sure that the different bugs, we found, we noticed on the ground, we fix them, and also we need to upscale it in terms of updating it in terms of new diseases or pests, and also to upscale it in terms of geographical coverage. It's true that in most of the West African countries we have almost the same environmental or climatic condition, meaning that we can use the app developed in Burkina and we can use it maybe in Mali, Niger. But when it's come to some coastal country, for example, the environmental condition may be a bit different. and it may affect the accuracy of the app. And then we are trying to maybe look for funds to upscale it in terms of geographical coverage, and also in terms of new diseases or pests we may find on the ground. In addition to that, is the day-to-day maintenance in terms of birds, and also in terms of user requirement. You need to customize it to meet the user's need, and also to make the use easy. Yeah, that's what I can say.
Okay, thank you. And you already have someone in place to do this day-to-day maintenance for a longer term.
Yes, we will have for now we have the one who developed it. The developer is still on board with us, and he's doing the maintenance. When we close it, and we have an IT department in the institution, and we can take over the maintenance work there.
Okay, thank you very much.
You're welcome.
Thank you. And a good question. I also had a similar one actually for the long-term, I guess, sustainability. I know that you said you're working with the ministry.
Yes.
So of course, now you talked more about maybe projects, getting more funding to expand, perhaps through projects. And then
Yes.
for long-term, ownership and sustainability, then that funding would it come directly from Wascal or from the ministry, or is there a plan around that? Because that's, I think, a big question when these applications are made, how to ensure they keep existing and working after the end of the projects that built them.
Okay, thank you for the question. For the sustainability of the app, the Ministry of Agriculture, it is a public service. Then we don't expect them to maybe give us funds to upscale or maybe to maintain. But what we want to do is to hand over the app to them, and we are going to do the maintenance work at our side, because we at Wascal we also work on agric-related project. And in terms of upscaling, when I talk of upscaling, I think of winning other project, winning funds from other funding partners, and maybe leverage this project to bid on another bigger one. One example is that we are right now implementing a project related to climate services provision to farmers. And in the framework of this project, we use this app. We train the farmers to use this app and to be able to monitor, to control the pests and disease on their farm, because they have gotten loans from one financial institution here. And then the objective is to help them through this app to limit the damages in terms of pest and disease on their crops, and be able to refund the money they got from the institution. This kind of arrangement we are trying to do to sustain the application. And we are also, we at WASA, we are non-profit, but what we want to do is to try to, because in the framework of the project we have a website. We are thinking on how we can use the website like to to collect some funds, either for the maintenance or maybe for upscaling the app. It's not big amount. Like we try to put an option as donation. Some people can give some coins for so then we can use it for the app maintenance.
Okay, thank you. We'll take our last question from Tavengwa before we move on to Balbina's presentation. Tavengwa, you can go ahead.
Thank you, Clay, and thank you for your presentation. I just have got two small questions. The first one is on the metrics in terms of use from the inception of this app up to now. How has been the numbers in terms of use?
Okay, thank you for the question. In terms of metrics, we got the metrics through our website, because when you download the app and want to use it, it is requested to use your email address to register, and through the email addresses, the metrics of users are recorded in the website. And as I right now, I think we released the app on May this year, May 2024, just at the beginning of the cropping season here in Kenya. And right now, I haven't checked the metrics this morning, but we are not far from 1,000 users. 1,000 users of the application during the rainy season.
Okay, and then my second question is that I understand there are a lot of different farmers. We've got conventional farmers, but maybe we also have got agroecology farmers, or we have got organic farmers. And how far are these accommodated in the app in terms of pest control? Because some of them, maybe they don't need, or they don't use chemicals, they use traditional methods. Are all these incorporated into the app for different farmers?
Okay, thank you for the question. Yes, there are different type of farmers, as you said, on the ground. But this customization of the app regarding the type of agriculture you practice, we have not integrated it yet in the app. But what we are trying to do is we can do it through other projects. Use the app and try to assess or monitor pests and diseases on the farmers, for example, practicing agroecological farming, and also use it for farmers practicing maybe biological farming, the one who don't use chemicals, maybe fertilizer or chemical pesticide to combat pests and diseases. But as for now, the app can be used for every farmer. Yeah. This differentiation in terms of practices is not integrated yet in the app, because whatever the type of farming you are practicing, you may find at a certain point a pest or diseases in your farm. But now, what is going to be different is that, are you going to combat it with biological means, or are you going to use chemical pesticide to combat it? And this is an option we have not yet integrated on the application. Yeah, we leave it for other projects to be implemented using our application.
Thank you.
You're welcome.
All right, thank you very much, Valentin.
Welcome.
I think as we're already running on time, so I'm gonna ask Balbina to take the floor.
Thank you.
Okay, thank you, Claire. I will try and share. I'm not sure if he has to stop sharing. Okay.
I think he has already stopped.
Yeah.
Just so we can see your screen.
Okay.
Perfect.
Yeah, thank you. Yeah, my name is Baubina. I'm from IHE Delft, and I'll present this work from my first objective of my PhD research. Yeah, we know that with climate services, these are also these decision-making tools that farmers use, in this case, just following on from the previous presentation, that farmers can use to make decisions about their farming. But what we see now is that there's usually a disconnect. There are a lot of these climate services that are produced for farmers, but then they are not really used in decision making. And that's where the idea of this co-creation comes in play, where there's this idea to go through these iterative interactions between the producers and the end users in the same environment, where they co-initiate and they explore needs, they co-develop information, they co-design the service, they also evaluate the prototypes that would have been made, and they all co-deliver the climate services to ensure that they're able to use it even after the code creation process has ended. So the idea is that, this is the hypothesis that has been put forward for a while, that co-creating climate services will then lead to them being used. So co-creation becomes this bridge that bridges the gap between the production of climate services and their use in decision making. But yeah, we still haven't done much work as researchers to unpack this co-creation black box, to really identify if this co-creation is leading towards use of climate services and how are they doing that. And we see that there is a lot of co-creation initiatives that are being launched in different fields, and also in and they're structured differently, shaped differently, but we are not really sure how effective these are at actually ensuring the use of climate services. So as part of my broader study, which is to uncover how this works in DRR sector, one of my objectives is to categorize the co-creation processes that are occurring and how they are being practiced specifically in the disaster risk reduction sector. And this will then expand the understanding of co-creation approaches in practice. So yeah, for the data collection and analysis, I'm not gonna spend much time here, but we underwent purposive and snowball sampling. If you have questions about this, you can ask afterwards. I'm not gonna go deeper into this, but we invited 126 stakeholders, and the criteria here was to identify stakeholders along what we call a value chain, where we have producers, we have these purveyors, and we have end users that have been part of a co-creation process and have specific knowledge on this. And we specifically went for co-creation processes in practice. These are done by commercial businesses, as well as in research as well, the co-creation processes that have been done through that, so that we can have a clear picture of what is going on in theory as well as in practice in different spheres. So we conducted document analysis as well of these processes and semi-structured interviews. And from there, we conducted thematic analysis and what we call an ideal type analysis, which is an analysis in sociology and psychology that we use to sort of categorize, in this case, co-creation approaches based on their within group similarities and differences, so that we are able to formulate typologies around a certain phenomenon we want to study, in this case, co-creation approaches. So we ended up having 33 case studies that we were looking at, and these are the areas where the case studies outputs were going to be used, the climate services. So we see a lot in the African region and then also Europe. And what we found was that we actually have 3 different types of processes that are occurring in practice. We have the information-oriented process, and the functionality-oriented process, and one that is an innovation-oriented process. So for the information-oriented process, this is the process where after the initiation of this co-creation, there is other stages do occur, but there is clear focus on the co-exploration of end-user needs. What do you need? How do you need it? And the co-development of climate information, specifically in research-based processes. So to understand what the users need. So what happens now is that this intensity of interactions. So during a life cycle of this co-creation, most of the time is spent negotiating these needs and how they can be realized. What we see is that this kind of service, it risks having useful and usable information, of course, but in the end, some other stages are then neglected, or they are done only in one meeting, for example. So then how exactly this climate service would then be used in decision making is then difficult to navigate if you didn't co-evaluate it using a scenario, for example. And it's also interesting that we found that when you involve end users mostly in these processes, they then tend to lack sort of motivation to attend these co-creation workshops because they feel you are not giving them anything in return. You have not given them some sort of an application, for example, or a prototype to play around with. But yeah, this kind of processes have been useful for stakeholders that are quite new to climate services because most of them are not clearly sure what they actually need, and you have to sort of negotiate that. So this kind of process is helpful for that. And also they are useful for when you are wanting to enhance information in a climate service that already exists and you just want to sort of tweak it a little bit. The second one is the functionality-oriented process. And as you can see, this is like a typical co-creation cycle. For this one, they focus more on how it will be used, in decision-making. So the design of it, and then they evaluate using a scenario. Am I able to make the decisions that I usually make, yes or no? And yeah, so most time is spent here. So they do have co-exploration of needs, but here they can have maybe a few meetings on that and a lot on trying to see how they can actually apply this in decision making. What happens here is that it's really, it risks getting too involved with the actual app and movement, so that at the end of the day, some new emergent needs that may come up might not actually end up being addressed because they sort of rush that process. But it's also useful for mostly all levels of users, but specifically if you look at those that are already working with climate services, they already know what they need. So they already know that the co-exploration phase is shorter. And we find that because these approaches normally have what they call an agile approach, where they have a meeting on the needs and the development, and they already start showing an app, what they can already do. There is high level of trust, and the stakeholders feel like something is going to come out of this process in the end. And these are also useful for operational services. And then the final one is this one is innovation oriented, and we see this mostly in the research-based co-creation processes, where we have like a 4-year project, And we have an additional step to this cycle where we have context matching. This is usually where these researchers that are part of projects, they sort of do research on which context their project would fit in. So it's unlike the other ones where the user might actually approach the providers for information. Here, sort of they're approached. And yeah, that's the editing stage and the intensity. So with this process, they try so much to follow the ideal process, giving so much time for everything. But then what we see is also that they don't end up finishing on time, and others get extensions, others don't. So there's already a haphazard way of closing up the project. And what we see is that they also risk developing very innovative prototypes and climate services that are often different from the policy environment in which they're working in. And what happens then is also that they are not used, these climate services. And yeah, we are running out of time, and they are also useful in exploring new ways to develop climate services and what could work, how to also trigger change within these policy environments. But yeah, what we also found is that, yeah, most of them end up not being used in the end. So bottom line here, I would just say that we have all these different approaches and they work in different contexts. So we need to also be aware that because of the assumptions that we have for these different processes, it now shapes the outcome. So for others, you end up with the concrete or the climate service that is heavy on the information and less on the practicality, and others heavy on the innovation and less on the practicality. So you need to now strike a balance if you are going to apply any of these. And you also, as a practitioner, if you're going to go in and select the type of process you're going in, you need to be well informed of the context you're getting into and understand how you're going to structure your teams as well. So yeah, I think we are running out of time, but I guess I'll answer some questions now. Thank you.
Thank you so much, Balbina. Very interesting. And for time, I think most people are okay to stay a few extra minutes. So don't worry too much. If people need to leave, of course they will go. Well, very interesting. Does anyone have a first question they would like to ask? Okay, then maybe I will start, and in the meantime, maybe other people will be also inspired.
Okay.
So in our project, so I'm going to ask a bit, yeah, if you have advice about yeah, how to transfer this information or how you would advise then based on everything you've learned. In our project, essentially, we have this tool of remote sensing, and we have different case studies where we want to use the remote sensing to hopefully be of yeah, help be a piece in the puzzle, let's say, to help communities deal with problems that they may have. So I feel like maybe we're linked a bit to the third you talked about with innovation.
The innovation,
yeah. So maybe I don't know. Maybe you can advise if you maybe some pitfalls that you see very often. You already mentioned some things that maybe there's issues with not finishing, or I don't know what what other pitfalls you would like us to have in mind when we want to do our work and we start talking to communities and so on. Because we're a bit between things, right? We already have our solution, but this not really our solution, of course, but let's say we have an idea of the tool we want to use, but we also want to make sure it's useful. And how would you tackle this?
Yeah, thanks, Claire. So what we have seen is that there is a tendency to then, so already the user agency, the end users are not the ones who approached you, so already it's on a shaky ground. But I think if now you have already identified them and just trying to work with them, you need to be very flexible in terms of changes, because they might need something completely different, a different solution to the one that you have envisioned. And you don't want a situation whereby you go there and you have this co-exploration of needs, but still give them a solution that you had in mind that won't work in the end. So being very flexible and also inclusive in who you inviting for these, I'm not sure if you're doing workshops, to make sure that you have different voices in there. And yeah, I think at the end, ensuring just a collaborative environment where you are sure that you are also learning from them and what they need, and then they are also learning from you and what you need. I found that most of the cases we've reviewed so far, those were the three key enablers to these processes. So, and what I also saw is that when there's a tendency to select case studies where you already have a built relationship with people there, but if there isn't any built relationship already with the people there, just allowing time to build some sort of trust with the communities that you're working with will actually help out in the end in terms of the level of acceptance you get as researchers, as well as the legitimacy of what you're creating for them.
Yeah, thank you. I think these are all things that we have to really keep in mind as we move forward.
Yeah.
Does anyone else want to ask anything to Balbina?
Going once.
Yeah, I think it was just a lot, and I think
Yeah.
in a way, we know these risks, these pitfalls, and the trick is to, I think it's important that you mentioned this flexibility, because of course we have this idea and what we think might help, but it might not be at all
Yeah.
what is required on the ground. And I don't know if you looked into that, but we also have this challenge that we're trying to, at the same time, push forward the science on some aspects, maybe on monitoring and at the same time, yeah, make sure that what we're doing can be useful to the community.
Mm.
And I don't know if you find this also with the climate services, but sometimes you're a bit in the loop, is that until you are able to prove that you can bring something useful, then it's hard to get the community involved. But then once you've sort of gotten that work to a certain level to prove it's useful, it can be very hard to remain flexible after that. So that's, I
Yeah.
think,
Yeah.
maybe it's the same thing as observed in these climate services as well.
Yeah, I think with the functionality oriented one, what we saw is that once they agreed on, oh, these are the needs we want to address, and this is how we can address it, they already bring up some sort of a prototype of, okay, this is what we can design. But once they get going with that, it's now difficult for them to include other emergent needs that come up along the way. Like, oh,
Yeah.
actually, when we had that meeting initially, maybe we can pivot a bit. We can include this so we can move around and do this. And now that process is no longer flexible because we already have something that we are working on. And it becomes a challenge. Then it's one of the risks that you find with these approaches. So I think the circle was created for a reason to have different stages, and focusing on specific ones is going to sort of unbalance everything. But then also trying to follow step by step has been seen to be not very helpful in terms of time. So it's a matter of understanding the context and the end users you're working with, and also the limitations of the researchers and what they can actually do for the communities, and then moving on from there.
Yeah, thank you. I think that's something we run into often when we talk to communities, is that also, for example, with remote sensing, but I suppose it's the same with climate services. Um, if there people haven't had maybe capacity building workshops around these technologies, those expectations can be very big,
Yeah.
and it's hard to manage them. So that's also, I think, why we sometimes resort to having a prototype to kind of show in a hands-on way what is actually
Yeah.
possible.
Mm.
Thanks a lot. So last chance, if anyone has a question. Also, if someone realized they had a question for our first speaker, Valentin, that you haven't had a chance to address, please feel free. Okay, so then I think we're going to close the session. Thank you so much to the two of you. I thought it was really interesting and to see the two different perspectives, a bit really on the ground and then the more academic analysis. So thank you so much. And I think
Thank you very much.
I think these insights will be good for our project also. So
Yeah.
thanks so much.
All right.
Thank you.
Pleasure.